It's my face. All right, let's talk about gravity. Yeah, that's what we've been working on recently, and so we're trying to figure it out. All right, so here's what we're trying to do. We've been trying to figure out what is the acceleration to gravity, and moreover, we want to see if something like this is going to fall at the same rate as something like this, and then even more so at the same rate as something like this. This is it's the bowling ball. It was my mom's. That's our idea. That we're working on here. And so how did we do that? Well, we on desks and tables and dropped balls. That process yielded some information. And it mostly got times that were like less than 1 second as we dropped stuff from a height of, at the most like close to 3 meters. All right, so we used E equals VIT plus 1/2 AT squared because we knew our initial velocity, and we measured our time, and we were able to calculate our acceleration based upon knowing that distance. So that's what worked for us, right? It worked for you, right? It didn't, you say? Why not? Did you take a look at your data? What was the acceleration supposed to be? What is the accepted value? Well, you look it up, and you see that the accepted value is 9.8 meters per second squared. How many of you got that? Just raise your hand. Go ahead. No? Okay. Some of you may have gotten that for like a single data point, but you may find that your averages kind of aren't that good. And so the question is why? Why exactly is that? And we're going to start to take a look at that today. But I'm not here. I'll be there. Okay, so I'm gonna have my assistant. We're gonna calculate actually your reaction time. So my assistant up here is going to drop a meter stick, right? Okay, and my job is gonna be to catch it. But we're gonna have to be careful in our setup, just like we were for dropping balls, right? In order to know. Let me get rid of that. In order to know exactly what your reaction time is. Some of you may have done this in biology, but we'll get to it. We'll get to that. So the idea is that I'm going to hold out my hand, and I'm going to hold my hand very, very still, whoop, like this. Okay, and the person is going to put the meter stick whoop, right at the top of my hand, right. All right, and in doing so, right, once it's there, right, let's set this up. Okay, so we have our meter stick, and my assistant is holding it up there, and the idea is I'm going to put my hand in here, and I want my hand to be right at the bottom of it, okay? And they're going to hold it very still. Hold it still, all right? And then on the count of 3, just kidding, you're supposed to be reacting. So they're not going to let you know when. It's going to be totally random, right? They're just gonna drop it, and your job is going to be to catch it. Now, you can see what I've got going on here. Now, on this side, we have our inches. We don't want to look at that. We want to look at, turn. All right. We want to turn it to our centimeter/meter side, because we need to have this in ultimately in meters per second. All right. But because my fingers, right, are going to close on this side, I'll be able to get a reading right at the top of them, right? Because my hand is going to be at the bottom, and because my hand is going to be at the bottom, when it's dropped, the meter stick will fall, all right? And it'll fall some distance, and boop, I'm going to try to catch it, right, as quickly as I can, and then I'm going to be able to look at the top of my hand and say that is the distance that it fell while I was reacting, okay? So that's the goal. So let's see this. What is that in my face? All right. All right. So we're gonna hold it still, and I'm gonna go. They don't say go. You don't say go. You just wait. You just wait. Okay, all right, so then they hold it up there again, and then that's the lab, all right? It's not really, it's part of the lab. All right, so they just hold it up there, and you're gonna do this 10 times, okay? So here's what you're going to get. You are going to get 10 distances. So this is a little bit different than what we did yesterday, all right? Because now you're going to know a distance, and you're going to be looking for a time of this thing falling due to the acceleration due to gravity, and initial velocity of 0 still, right? Because this, right, this is starting at rest. All right, so the idea is we have a distance, we have initial velocity, we have an acceleration, and we're looking for a time now. So in this case, we're going to use the acceleration due to gravity. We're going to use it this time instead of trying to find it. So different than the other. So we're still going to use the equation d equals VIT plus 1/2 AT squared, but this time we are going to find the time. All right, so you're going to find your average time is really what we're doing, and everybody needs to do this. So everyone's going to take part in this. Everyone's going to calculate the reaction time. So once again, you are going to hold a meter stick just above your hand. Right? Can't be touching. If it touches your hand at all, it doesn't count. If it slides past your hand on the way down, doesn't count. You need 10 good trials. So that means it's not touching your hand, it's not touching your hand, it's not touching your hand, right? And then the person drops it without you knowing. And you're just reacting to it, and you're going to close your hand. No guessing, right? No guessing and saying, I think they're going to drop it now. I think they're going to drop it now. I think they're going to drop it. Just, right? So just they drop and you react, all right? And you're going to get measurements. Make sure they're in centimeters. Make sure you convert them to meters, right? Otherwise, your math will be all wonky. All right, and you're going to do it 10 times. Everyone's going to do it 10 times. Take the average time, take that average time, your initial velocity of 0, your acceleration of 9.8 meters per second squared, and calculate that time using the equation d equals VIT plus 1/2 AT squared. That is your goal. That will be your reaction time, and then what I want you to think about is how does that reaction time compare to the data that you got, earlier, all right? So good luck with that. Have fun. Thank you. All right, and see ya.